So now we proceed with the first stage. So there are some calculation mistakes. You can put it as 0.5 K and this will be 45.3. So we can determine the second stage current gain, input impedance and the voltage gain. Similarly, now we can determine for the first stage. So to determine for the first stage, it is a common emitter configuration. So we can have AI1 is equal to minus HFE by 1 plus HOE into RL. So here RL coming here. So the RC1 is the load resistance for the first stage, but that will be shunted with the input impedance of the second stage. So we have to take the effective load resistance RL. RL is equal to RC1 parallel RA2. So that's equal to RC1 is 5K, 5 into 10 power 3 into, then RA2 is 228.5K to 10 power 3 divided by 5 into 10 power 3 plus 228.5 into 10 power 3. So this value will be, we can take it as RL1 for the first stage. So that will be given as 4.9K. So now we have to substitute RL1 equal to 4.9K. So remember that the load resistance for the first stage cannot be RC1, it will be combined with input impedance of the next stage. So that's what I told earlier, you have to proceed from the last stage to the first stage. That's why we cannot determine instantly for the first stage the current gain, because we don't know this value unless you find this value. So that's what we get determined here. So now we can substitute this, you will get HFE value is 50, so minus 50 divided by 1 plus HOE is 25 into 10 power minus 6 into 4.9 into 10 power 3. So this gives the value minus 44.5. So now you can determine the input impedance for the first stage. So you know the formula is HIE plus HRE into AI1 into RL1. So by substituting the values, HIE is 2K 2 into 10 power 3 plus HRE is 6 into 10 power minus 4 into minus 44.5 into 4.9 into 10 power 3. So this gives the value RI for the first stage will be 1.87K. Then you can determine AV1. So that's given as AI1 into RL1 divided by RI1. So we can substitute this value. AI1 is minus 44.5 into RL1 is 4.9 into 10 power 3 divided by RI1 is 1.87 into 10 power 3. So that will give you AV1 is equal to minus 116.6. So only for common emitter, the voltage gain and the current gain both will be greater than 1. Forget of the minus sign, that will be got by conventional methods. Only for whereas for common collector the current gain is higher, whereas the voltage gain is less than 1. So now we have determined the individual current and voltage gains for both stages. We can also determine the overall voltage gain just by multiplying the individual values. AI1 into AI2 will give you the overall current gain, and the AB1 into AB2 will give you the overall voltage gain. Now we have to determine the output impedance. We determine the input impedance, output impedance. So output impedance cannot be determined directly. We have to determine by means of output admittance, because we have got the formula only for output admittance. So now here we have to start only from the first stage. To determine the output admittance, we cannot start from here. The reason is the output admittance is related with the source resistance. So for example, you see for first stage YO1 is given as HOE minus HFE HRE by RS plus HE. This is the formula for output admittance. So that involves the source resistance RS. So if you determine for the second stage YO2, what is the value of RS, the source resistance, we don't know. Okay, so we will determine this, whereas for the first stage it is given as RS is equal to 1K. So now we can determine this. HOE is given as 25 microampere per volt into 10 power minus 6 minus HFE is 50 into HRE is 6 into 10 power minus 4 divided by RS plus HIE. RS equal to 1K, that is 1 into 10 power 3 plus HIE is 2K, 2 into 10 power 3. So if we determine, the value of this will be equal to 15 microampere per volt. So but we have to determine the value of RO1, the output impedance, not the admittance. So you can take the reciprocal 1 by YO1. So this gives you 1 by 15 into 10 power minus 6. So that will become, if you see that R1 is equal to 66.7K. But again this is only RO1 here, but this will come in parallel with your load resistance. So your RO1 dash, the effective output impedance R1 dash is given as RO1 parallel RC1. So now if you take this one, that is 66.7 into 10 power 3 into RC1 is 5K, 5 into 10 power 3 divided by 66.7 plus 5 into 10 power 3. So this you will get R1 as the first stage as 4.65 K. Okay. Now we have to determine for the second stage the output impedance. So again we will find first output admittance. For the second stage it is common collector, so HOC minus HFC HRC divided by RS2 plus HIE. So we can call it as RS1. So this is source resistance 2. So what is the source resistance for the second stage? We don't know. So the source resistance is nothing but the effective load resistance, what is output impedance coming to the first stage, will act as source for the second stage. So now we can take this RO1 dash as RS2. So here RS2 is equal to RO1 dash. Remember this point. So for the first stage, the source resistance is given directly. For the second stage, the effective output resistance combined with the load resistance and its output impedance, that will act as the source resistance. We can take RS2 is equal to RON dash. So now we can substitute these values. HOC is given as the same thing, 25 to 10 power minus 6 minus HFC is minus 51, HRC is 1. So that minus and this minus will become plus, divided by RS2 we have to put 4.65 plus, so this is HAC. HAC is also 2K into 10 power 3. So if you determine this YO2 will be 7.7 into 10 power minus 3 ampere per volt. So this we have got microampere per volt, this is ampere per volt. So now we can determine from this RO2. So RO2 you will get 1 by YO2, so that's equal to 1 by 7.7 into 10 power minus 3. Okay. So again this will has to be combined with, so this is only RO2, but I have to take again the load resistance in combination to get the effective output resistance. So RO dash is equal to RO2 parallel RE2. So we can take this 1 by 7.7 to 10 power minus 3 with 5K. You will get this value as RO dash is given as 127 ohms. So the output impedance for a common collector is very less. It is just only 127 ohms. Okay. So next we are left with to determine the overall current gain and voltage gain, or we can say the last class I have given two methods. The first method you can determine the current gain and voltage gain individually, then you can get the overall voltage gain. Without finding the overall voltage gain, you can directly find the overall current gain using the second method. So that we can work it out now.